So on your blog, right under the name, you have a subtitle that reads, "Ever tried, ever failed, no matter, try again, fail better." Is this a motto of yours?
Yeah, and it's a quote from Beckett, the playwright, and it really stuck with me because what I found is I don't know how to do things in a particularly smart or intelligent way, sort of better than anybody else.
That's very humble of you.
No, I mean it's an honest assessment, but like what I can do is see if I can get the iteration actually going. And that whole, I mean, anybody who's done any software engineering or data science knows you try something, it doesn't quite work, but if you can make it so that that cycle is fast, you can actually learn really fast. You know, in ML terms, if you can bring that epoch time down, then you actually have a chance to, figure stuff out. So it's really trying to capture that idea of getting those iterations in, not being afraid, trying to set up things where you aren't betting everything on one big, uh, you know, the first time you try something, really trying to keep iterating on it and getting that iteration time down and just being comfortable with like figuring out. I think it was Thomas Edison had a quote about he tried 1,000 different types of light bulbs, and he was excited because he'd found 999 ways not to make a light bulb, and that was really useful.
What's your take on like experiential learning? I remember first hearing about that, and then where someone was kind of jokingly being like, "Oh yeah, I'm an experiential learner in that I'm like too dumb to take like good advices, so I need to make the mistakes myself." I heard that, I was like, "Oh my gosh, that's me."
Yeah, I mean, there's definitely part of that. I need to touch the stove myself. Yeah. Really figure out if I'm going to get burned, and I usually do. And a big part of it is actually trying to listen to all the advice I can get, but a lot of advice is contradictory, and a lot of advice is very dependent on the particular circumstances and the particular context. So you've got look before you leap, but he who hesitates is lost. You you often find yourself in that sort of situation. So a lot of the challenge is either digging in with the person and understanding the details of how they came to their conclusions, or just trying to set things up so that you can course correct very quickly if you start to see signals that things are headed in the wrong direction.
I like that. I like that. Okay, so coming back, so a few weeks ago, you launched this AI in the box. Can you tell us more?
Yeah, so I'll actually give you a little
Hey,
preview.
live
Oh,
demo, let's
wow. That's
go.
awesome. Oh, wow.
Yeah,
As we are speaking, it's actually transcribing it and showing it on the screen. That's so cool.
yeah.
Wow.
And it's actually understanding my speech, which I am very impressed because
Ah,
Vanek can't do that a lot of times. So
true. Very
Yeah,
true.
and I know, for example, I have European friends who have to put on a American accent to get their GPS systems to understand them. And one of them was actually saying, "Yeah, I just put my finger on my nose," and told which my American wife was, "We don't sound like that."
wait, that's actually a bit rude because you're not American.
I know.
Wait a minute.
See, I'm just trying to offend everybody here.
Hey, show them the cool demo. They'll be impressed. They'll forget what you said.
Yes. But this is all based on, we've taken OpenAI's Whisper model, and we've turned it into a real-time, speech to text, because it's a batch model, that takes 30 seconds of audio. So by default, you'd be waiting sort of 30 seconds and doing a chunk at a time. We've managed to accelerate it, significantly on this. It's all running locally, I should mention, on this little AI in a box, sort of
Mm.
credit card sized board that's very similar to like an Orange Pi. And I'm so excited about being able to do speech to text as like a local just utility that you can have lying around. I'll do one more demo as well.
Oh, yes,
Just
please.
we also have, as well as the speech to text, if I say go into chatty mode, it's now in a large language model that's also running locally. And then if I ask it, are you going to destroy humanity? This is always one of my favorite prompts.
Oh,
See,
wow.
that is slightly terrifying.
Oh, that is, I mean, the demo is incredible. The responses at the end, yes, it's very interesting.
Yeah, it's like, oh, and by the way, I may intervene. But just to show like a practical use case that actually came up yesterday when I was talking to a customer, if I ask it, what's the most common problem with a fridge?
Oh,
So
wow.
Interesting.
the reason that was interesting was I was talking to a company that was involved in warranties for home appliances. And the idea of having a user manual that's
Hmm.
actually embedded in the device, which could save money on their call centers and also potentially save them having to send people out to repair devices. Suddenly, that large language model goes from being kind of this, you know, abstract thing that you use a web page to interact with to something that's actually able to understand natural language, able to ask you questions to help you diagnose a problem. I was just really excited by, you know, being able to do speech to text to get the text and then being able to use large language models to understand natural language. I think that that's going to be a game changer.
Oh.
Okay, this is very exciting. So there's three topics I want to touch on. So one is so use cases. The other one is sort of the specs, right? Like how does this comparing to, the latency and all that. And then the last
Yeah.
part is deploying, like how do we update? Okay, so maybe starting the use cases. So can you give me one use case that's you found very useful, and then one use case that's like hilariously silly or just bad?
Yeah. So one of the things I really want to be able to do, and kind of the idea behind useful sensors, is I just want to be able to look at a lamp, say on, and have the lamp come on. That should just work. We have all of these like Alexa and Siri and all this other very elaborate voice control systems, but they don't work like we work. They don't work like interactions with people. I just want to be able to build a really simple interaction with these everyday objects. So I think that's the most useful. There's been people actually building for the fun use cases, people building animatronics for theme parks.
Oh,
So, those things on rides that sort of, or things that leap out of you in haunted houses.
yeah.
And being able to do speech to text
Oh,
and
interesting.
actually interact with these things. Like I love the idea of actually being able to, you know, have something that's like one of these creepy monsters, or even like was it Chuck E. Cheese has those bands that play banjos and things. But you can actually talk and interact with them. I think that's a whole new level of creepiness that I'm here for.
So the demo that you showed was really cool. And I think one thing which was obviously very different from how you interact with assistants, like let's say Google or Alexa, there was no trigger word. Like you weren't waking up the device. You just said what you wanted to say and the device responded. And I was reading about AI in the box, and this is all happening locally, right?
Yep, it's all running with no network connection. So that's one of the kind of amazing things. And a lot of what we're doing with, like, for example, the lamp use case is we have this little person sensor, which is this little board here, which
Hmm.
you can buy for sort of $10 on SparkFun. And this tells you whether somebody's looking at
Okay.
you.
Yeah.
It has a camera and a microcontroller, which is running like an ML model. And so you've got that social mimicry of actually being able to tell when somebody's, you know, connecting with your gaze. Because we really wanted it to be similar to the way that you interact with people. And that is such a key dynamic. You know when somebody's talking to you because they're looking at you.
Yeah, that is incredible. I think one of the aspects that is super important to call out is the privacy piece, because I know many of my family members who don't work in tech, they use these assistants all the time. And they would come and say, "Hey, you work in tech. Do you know if this thing listens to us? Because I spoke about a random thing with a friend of mine and I saw an ad on one of the platforms. So it seems like it's listening to me." It doesn't matter how much you tell them, yes, it's secure and they're not listening like you think they are. They don't tend to believe that.
Yeah, because people don't trust big tech companies.
Yeah.
Like, we've burned through a lot of goodwill over the last like decade or two, and they're rightly skeptical. And what it comes down to, like when I was at Google and had the same experience, I would be able to say, yeah, no, I know that code. We're not listening to you when, the assistant is off, but I can't prove it because it's all just in a massive code base inside Google. And a lot of what we're trying to do, like with the on device stuff and with these little, sensors, is build systems that the privacy can actually be checked by a third party like Underwriters Laboratory, Consumer Reports, somebody else who can actually look at the equivalent of an ingredients list for the data that's being shared and confirm that these little, subsystems aren't capable of sharing like the camera feed,
Hmm.
for example. You can just get information about whether somebody's looking at the device, like the metadata. So that's a really important driver for what we're doing too.
Coming back to the use case piece, one of the things I read about AI in the box was you can connect like a device to it which can take keyboard input. So as you're speaking, it can become more of a transcriber or a note taker where you can have a document with all your notes. That seemed super cool. And one of the things I was chatting with my wife last night was we didn't know about, or she didn't know about AI in the box at the time. And she's like, one of the amazing use cases for AI could be where you have this device at home and you can talk to all your appliances. Where you could say, turn on the stove or turn on the
Yeah.
microwave for 30 seconds without having to go and press the button. So, do you see this use case going in that direction where it becomes the control box to connect to various things?
Yeah. And actually, one of the things we're trying to do is make it cheap enough and small enough that each individual appliance can have its own voice. So instead of having a centralized box like we do with AI on a box, my dream is to get it down to 50 cents for speech to text. And then we can actually have, the microwave can know when you're looking at it and it can just listen out for that voice. And the other thing that would be really nice there is it should work as soon as you plug it in. Like most of these connected appliances never actually get connected to Wi-Fi because it's such a pain. So having something that just works out of the box is a really important value for us too.
One thing that I was surprised when I first saw it is just how small it is. You hear about, right, like billions of parameters that's associated with the LLMs, and then to deploy it on your server. So one question is like, right, how are you guys able to like shrink it down to that size? And then the second, I guess, is this comparing to like Alexa or Siri. So the advantage there obviously is you know what's going on in the hood, under the hood, and then you can actually access a lot of the stuff. But is the model is also superior, right, in terms of like how they're doing natural inference?
Yeah, I mean it's hard to compare because they're doing the inference in the cloud. And I will say,
Right. Sorry, that was a dumb question. You're right. It's
yeah,
on
and
comparison.
and I don't want to particularly because I worked very closely with the Google speech team. I wouldn't be surprised if their models actually beat us in in some of the word error rate scores and things like that. And so I don't want to sort of you know set ourselves up for that sort of competition because there's been so many smart people on all of those teams. They've had hundreds of engineers working for years, and this is something that has been put together by a small startup. But what I will say is in practice it's actually worked really well. And a lot of that is down to OpenAI's new approach with Whisper, where instead of taking a lot of labeled speech data, which is very expensive and time consuming to produce, they've actually just taken sort of semi-structured data off the web, but lots and lots of it to produce their transcription engine. So just to give you an idea, but we also believe that this is by far the best quality solution that's outside of those, Google, Amazon, and Apple.
And how are you guys able to deploy the model on such a small chip?
So a lot of it comes down to, there's no single magic bullet. And we are building on top of a lot of other open source teams' work. But we have, for example, the useful transformers framework that lets us use the NPU that's present on this rock chip board, on this rock chip SoC.
Sorry, the NPU is like a neural processing unit of sorts?
Yeah, sorry, I should have spelled that out. And so that lets us run twice as fast as any of the other solutions we've seen on this device, and really helps us get that latency down, which is absolutely key.
Yeah.
And so it really is just a lot of stuff around quantization, around, acceleration, around all these different ways to kind of deploy and squeeze stuff into. And on the large language model side, like we talk about billions and billions of parameters, but if you think about that as 8 bits per weight parameter, that's a few gigabytes. So, it's actually in the scale of things, even for, single board computers, they're large language models by machine learning terms, but they're actually well within the, capacity of fairly low end hardware to run.
Can you speak a little bit on quantization? I know that's a topic that you're quite passionate about.
Yeah, definitely. I mean, I've been on quantization since I was actually doing a retrospective for ICCV on quantization, going back through sort of the history, and I've been working on it, I think, since 2013. Initially 8-bit, but there's been so much work now around 4-bit and 2-bit that it's really, the whole field has exploded. And a big part of that is because a lot of these large language models are memory bound. So this is something new. Like convolution networks are usually compute bound. So, you really just have to throw more arithmetic units at the problem to speed them up. But because large language models are just doing these big fully connected layers, essentially, through transformers, and they don't really have large batches, it ends up, you just basically you can estimate the speed usually of a model by looking at the DRAM transfer speed, and that's the main limiting factor. So that means quantization actually helps speed things up because you reduce the memory traffic and you instead do you do more with the unpacking compute logic. So it's been really interesting seeing how it's gone from being something that's just about meeting these kind of constraints in terms of how much memory and storage you have to actually being a latency and throughput thing. Like,
Right.
and you can also get a lot more elaborate with the quantization schemes. So they aren't linear encodings. They can use lookup tables or complex functions. So yeah, it's been, I have, unfortunately, I've not been as hands-on as I would like over the last year or two, but it's been fantastic seeing everything that's happened in the field.
I remember for convolution, so for vision tasks, convolution networks, a lot of times when you quantize, you have to retrain the model, right? Because it actually results in different things. Is that still holds for language models as well?
Actually, I've seen a lot of work where people have been able to go down to 4-bit, for example, without doing retraining, and sometimes even 2-bit.
Wow.
There is some accuracy loss, but not, it's not unworkable. And what I've seen is that accuracy improves when you are doing quantization aware training. But the fact that you can quantize these models sometimes without having to do that retraining, it kind of makes me think that there's a lot of redundancy. Like they're over parameterized, or however you want to call it. Like there's sort of room to kind of represent the same information with fewer parameters, because being able to compress it well is usually a sign that there's there's a lot of redundancy there. So anyway, that's just a sort of a gut feeling.
And so the last part, in terms of like deployment, when new models like come out, how do you see the like what is it? Throwaway models? Sorry,
Oh, disposable ML
disposable.
frameworks.
Sorry, yes. So are you able to just like kind of grab these and just deploy it on the box like things advance?
Um, yes, but what I see happening a lot more is with traditional ML frameworks like TensorFlow and PyTorch, you expect to be able to just keep the framework the same and just bring in new models as data files, essentially representing the architecture and the weights. If you look at things like GGML and what we're doing with the use of transformers, there's a lot more work involved in supporting a new model from the framework side. Like they don't claim to be ready to bring your own model, at an arbitrary model and have them just run. So there's actually some coding work involved to bring in new models. And the reason that I think that's worth it is models are actually changing um, much more slowly. Or, another way of looking at it is a lot of different tasks are now able to be solved using one of a handful of different models. So the effort, putting in extra effort to support models in code is a worthwhile investment, especially on the inference side.
How do you compensate that with, or it's a trade off? In this case, if you have a specific framework that works with a set of models or a single model, you can have a new use case really quickly deployed. But then at a company who has a bunch of these, one of the questions that is often asked is, if every use case uses a different framework, then the maintenance cost, the cost to change them, update them, any instrumentation that you need to add to those frameworks becomes increasingly more expensive as you have n plus one. So, how do you see that being traded off with these disposable frameworks?
Yeah, and that's a really good question, and it's something that haunted us at Google and is the reason that TensorFlow was the sort of rallying point around which we tried to get everybody to use the same framework for those maintenance reasons. I think that we might have to think about reusability at a different level. So if you imagine instead of the like machine learning sort of architecture and weights and things being the bit you share, maybe we can actually have underlying matrix multiply implementations, the old school blast gem function for matrix multiply. Maybe that's the point at which we expect frameworks to share common implementations. And then everything else can be done very much in a much more sort of idiosyncratic way for different models. Or maybe it's something like we have the CUDA-NN library interface, and that's what all of these libraries share a common layer. So I think we just have to be more imaginative and more flexible on the infrastructure side to support, because it clearly makes a lot of sense for application and product people. If it's less work to write your own framework to run a model than it is to figure out how to use this kind of, massive crawling horror of a framework that includes everything, then that's really a sign that, we haven't done our jobs right.
And going back to the deployment piece for a second, so this AI in the box, it's a complete solution. So, like you said, you plug it in, ready to go. Have you figured out, like, once you have clients who have these devices, if and when you need to, let's say, add a new model or use something else, have you figured out how that would be deployed to these edge devices?
Yeah, well, send them a new hardware. No, that's a bit of a glib answer, but especially like the way that we think about this is, if you think about a temperature sensor or a pressure sensor or an accelerometer,
Yeah.
you don't expect to be able to do software updates on them.
Right. That's right.
They they work the way they work out of the box, and you build a system around the way, around their sort of, limitations and capabilities. And we as software engineers, it makes all of us nervous not being able to update code because it's like, oh, what if we ship a bug?
Yeah.
But for things like speech to text, I think that we come up with, the best solution that we can at a particular time. People then build a system around that, and it would often actually be pretty disruptive to make changes
Hmm.
because you have to kind of QA, you have to
Yeah.
do things like check the security, all
Yep.
over again,
Yep.
the security and privacy if somebody has given a certification. And uh, usually these devices also aren't necessarily under a subscription model,
Hmm.
which is what we're used to on the web and for phones and things like that. If your light switch is able to understand you, you don't want it relying on update servers that may get hacked over its like 20-year or 30-year lifetime. Imagine being on the hook for maintenance
Yeah.
for
That's
decades.
terrifying.
Yeah, it's terrifying. So for a lot of the companies we work with, having something that just doesn't have that liability of, you know, updatability is really important for them. Like they want something that works. And then, if something really new and big and that's a big change comes along, they want people to buy, next year's model. So
Another follow-up on customizability. So if, say, someone has like a private corpus of like text that they want to be able to, like the model to be able to reference, say like recipes for cooking that they really like, how would that work in this context?
yeah, we actually have one of our interns who's based at UT Austin is doing his PhD on how to create, we often call them tiny large language models that are actually able to be trained on very specialized knowledge. So, like I was talking about with appliances and having user manuals built in
Yeah.
to the appliance that you can talk to, there you'd feed the like user manual as, or maybe the customer support sort of guide as the source. And, in your case, you might feed in the, all these recipes as the source and then have the large language model able to answer questions about it. I'll share some links after the podcast to Evan's work because I think that there's a big opportunity to have something, maybe it's only hundreds of millions of parameters that encode this kind of specialized knowledge. Another thing I'm really interested in is, if you think about home improvement stores, I would love to put one of these boxes on every pillar so you can walk up to it and press a button and ask, okay, where are the nails?
Oh, yes, please.
Sure.
And and in that case, you really want to be able to just feed in like a CSV file, like a spreadsheet of all of the parts and where they exist. So I see a massive amount of potential in being able to set up large language models with these specialized domain knowledge.
And is it possible to do it in such a way that it doesn't involve like retraining, where you do need the compute in order to do it?
We do think that there's ways to do this with fine tuning.
Okay.
I think that, how much training is involved is still a research question, but we don't expect you to have like OpenAI's GPU sort of cluster in order to be able to do this. That's our hope.
I see. And have you guys explored? So, I read earlier about where you can do like kind of a multi-shot learning, which seems a bit janky, but you're literally just like, hey, like the first step, right? It's like just take in all this corpus, and then the step two is like I'm going to ask you questions about it. Like, have you guys
Yeah.
test that out? That out is that usable?
I haven't actually tried that yet. That's kind of similar in idea, I think, to some of Evan's work.
Cool, cool, cool.
Yeah. So when I share that, hopefully that will
Yep, I'll check
uh
out the link.
honestly, I'm I'm CEO now, so I'm kind of out of my depth on a lot of the technical questions. Like, I'm just nodding and smiling in meetings now when people talk about stuff.
So speaking of that, a nice
Yes.
pivot. So after 7 years of building TensorFlow Mobile at Google, so you founded the company Useful Sensors at the start of last year. Like, what made you decide to do that?
Um, it's really hard to put out hardware at Google because there's such a reputational risk. If you think about something like Google Glass, like there was such a backlash to that that at any big company, I think if you're bringing, it's a lot easier to open source software and models, but as soon as you're actually, and even like to spin up something that's on a new app or a new website, but bringing out something that's actually under the Google umbrella, that's a piece of hardware, that requires a lot more approvals because of the potential reputational impact. So, I really wanted to build things like the AI box and these little sensors and things like that as a way of getting out these ML capabilities into the hands of people who would not necessarily want to particularly learn ML, but would want to benefit from some of the things that it can do. So really the only way to do that was to do it as a startup.
So you were a CTO before you joined Google. You were a tech lead at Google, and now you're transitioned into a CEO role. And as you were you're meeting with clients. You're thinking more about the business than being more hands on. How has that transition been for you?
Oh, really hard.
Say more. Say more.
Yeah, well, when things get tricky, my default is to start trying to code up a solution. And that's not the right thing to do. Like, especially, for example, in business development, I we recently got a first full-time sales employee, Terry, and he's only been with us for 2 months, but he's already been like, I've learned so much about working with especially business customers and B2B from being with him, and he's made a massive difference to the whole company. And it's really, looking back now, I see that a lot of my first 12 months I was doing meetings with companies, and there was interest, but I was not driving things to actually get contracts closed, get stuff over the line, actually really do the all of the specialized work that's involved in business development and sales to make this stuff happen. So, yeah, and hats off to one of our VCs, Mike Dauber at Amplify, who was very, very. He's been super supportive, but he also was extremely
Persuasive.
made persuasive around. You got to get somebody on the sales side, Pete. And I honestly was like, I was listening, but it wasn't at the level of urgency that it should have been. And he really managed to get me to do that, and it's been a revelation.
I think fundraising is another part that would have been new as compared to being at a company. But again, you're asking for funding, but with some projects
Yeah.
like TensorFlow, it's funded. The conversation you're having is very different. So how is that like?
I mean, one nice thing was that, I spent probably a year in like 2010 going around every single VC in the valley and getting told no. So I actually had, before we got the funding that we needed for Jetpac, my first startup in the end. And so I actually have spent a bunch of time on the fundraising before. And luckily, I've actually got to know a bunch of these over the years. And most of the VCs that we're working with are people that I've known for more than a decade. So that has been really fantastic. It's been wonderful working with them. And we are in a weird area because we're AI, which is, has a lot of momentum behind it, but also doing hardware,
Yes.
which nobody in the valley pretty much is familiar with. It's very rare to have startups that are doing hardware. So we're in this really interesting position from the fundraising side.
Well, absolutely. I think, as you mentioned on the hardware side, like doing hardware is one of the hardest things. Software scales much better. And you see this in venture funding, you see this in just the number of startups trying to do this. And like all of the things like labor is expensive, A/B testing is hard, so many challenges with hardware, number of things that can go wrong. So, how are you thinking about just being able to monetize the products that you build over time? And any advice for other engineers and some of our listeners who might be thinking about this on how they can think about if they want to do something in hardware space?
I mean, I guess the first advice would be don't.
I saw that coming. I saw that coming.
Yes, I thought you might. I mean, it is, and I like hats off to, I'm coming at this as fundamentally a software engineer, and I'm learning about hardware. I can barely solder, so we've had a fantastic team who've made it work, but just the timescales involved with hardware are mind-boggling if you're coming from the software world. Sort of 6 to 12 months just to put the initial version together. Waiting for months on factories, trying to get all of the components together. It's an entirely new world of problems that you're kind of exposing yourself to. So, if at all possible, try and find some way to at least mock up your stuff on the web. Like we've been emulating what our devices do as web demos, so that we can at least share them with prospective clients a lot more easily.
I see.
Yeah, no, that's advice one, don't. That's an important one. So I know we are running up against time, so I want to capture a few questions before we go. On your blogs, by the way, you're a prolific writer, and you mentioned on your blog you think through writing. I think it's incredible. I want to talk a whole lot about that, but maybe another time. On one of the posts you had captured where someone told you this: training costs scale with the number of researchers, inference costs scale with the number of users, and you made a prediction there. Can you tell us more about this?
Yeah, so it's this idea that if machine learning is successful, even though training an individual model might involve, hundreds of GPUs for weeks, that model, once it's in production, if it's reaching hundreds of millions of users for years, even though the individual inference cost is, for each, call to the model, each inference is a lot smaller than training, an epoch of data, the number of users and the amount of time that it's going to be used for means that the amount of compute that's going to be spent on inference is going to be much, much larger than the amount of compute that you spend on training. And a whole bunch of interesting kind of things flow from that.
I guess one of your predictions there was NVIDIA might not stay as is for much longer, considering how just the ecosystem is evolving as we have these more use cases that come in for inference.
Yeah, and that was me being a bit spicy. There was something in my cereal that morning, but it was this idea that as researchers, we really need convenience to be able to experiment with different models. And you also need the absolute lowest latency and highest throughput you can get, because the limitation almost all the time is how long the model takes to train. Which is where NVIDIA wipes the floor with everybody. So for training, they are going to be the kings for the foreseeable future. But for inference, because the total costs for inference are going to be so much higher, that's where this idea of disposable ML frameworks and doing custom coding to support that use case, it becomes a lot more sensible to invest a whole bunch of engineer time to take a model that's, for example, I heard something like, Chat GPT takes 4 cents per call to return a result. So if you imagined hundreds of millions of API calls, a month or something like that, suddenly it becomes totally sensible to take a bunch of engineers and just say, hey, take this particular model, even if we only use it for a year or 2 years, the amount of money we're going to be spending on inference is so high, it's totally worth a bunch of highly paid engineers optimizing and profiling and doing special purpose stuff to speed things up. It will pay off very quickly when you're, spending that much. And part of that might be moving over to something that's not a GPU to execute this stuff.
Yeah, and I think cheaper inference also results in more use cases like AI in the box, which enables a whole lot of economies of scale.
Exactly.
Pete, this has been awesome. Thank you so much for joining us. Before we let you go, is there anything else you would like to share with our listeners?
No, thank you so much for having me on. This has been fantastic.
Awesome. Thank you so much for joining. And I think you have a crowdfunding campaign for AI in the box. We'll make
Yes.
sure we link that in the show notes, and we highly encourage our listeners to go check it out. And thanks so much
Awesome.
again, Pete.
Okay.
Thanks, Pete.
Thanks so much, Lonak. Thanks, Guang.